Okay, Math 9. Math 9, we're actually going to do some new stuff today. We're going to work on section 8.2. Not hard, won't take long. This is on what is called reflections. There are several different types of reflections. We're going to look at two of them. So, hey, sorry, I have a dog at my feet. Nope, this way. So if you have, let's say, a triangle, and I'm just going to make up some points here. Let's say you have a point, I don't like 1 and 1. Let's say you have a point at 2 and 1, and you have another point at 4 and 1, and you have another point at 3 and 4. Okay, so it makes this triangle. When we reflect something, it is exactly what it sounds like. Wicket, lay down. Wait. It's exactly what it sounds like. It is moving it. Wicket, stop. Lay down. It is moving it, and right now we are going to reflect. The way they put it is on an axis. No, go right. Go. Stop. We're going to reflect it on an axis. We're going to, if I said to reflect this across the x-axis, what that would mean is if I could fold this whiteboard, if I could fold it along the x-axis line, where would this end up? And it would actually end up like this. Give me 1 second. Stop. Lay down. Down. You wait right there. It would actually end up down here. So what would those down here points be? This would actually go from 2 and 1. I still went forward 2, but instead of going up 1, I went down 1. So it becomes 2 and negative 1. And again, I went over 4, but instead of going up 1, I went down 1. So it's 4 and negative 1. And I'm still going to go over 3, but instead of going up 4, I'm going to go down 4. So it's 3 and negative 4. So what I want you to notice is that when you reflect on the x-axis, what happens is you change the sign of your y values. So to reflect across that x-axis, what happens is your y values, the number doesn't change, but the sign does. All right? So what if I wanted to take that black one now and I wanted to reflect it on the y-axis? In other words, I wanted to fold it across that y-axis. Where it would end up would be here. Because you would take it and you would flip it over here. So instead of going forward 2 and up 1, I would go back 2 and up 1. So back 2 and up 1. I would go back 4 and up 1, and I would go back 3 and up 4. So when you reflect in the y-axis, what happens is you change the sign of your x values, okay? A lot of people get that confused. They think if I want to reflect in the x, I change the sign on my x. That's not right. If you want to reflect on the x, you change the sign of your y values. So on page 303, they have an example, even though I just kind of did one. they have an example on page 303. My eraser is it's leaving black smudges everywhere now because it's got so much crap in it. So, all right. So, for the example on the bottom of page 303, it says triangle DEF has vertices of 2 and 6. So 1, 2, 1, 2, 3, 4, 5, 6. That is D, I believe they said. E is 4 and 1, so 2, 3, 4, and 1. That's point E. And F is 7 and 4, so 4, 5, 6, 7, 1, 2, 3, 4. So make sure you connect the dots to make that triangle shape. Don't just leave it as separate dots. So we have the triangle. So what they want us to do, it says draw the image after a reflection in the x-axis. So I've left this up here to remind us if we're going to reflect in the x-axis, we just change the sign of our y values. So instead of being at 2 and 6, I still go forward 2, but instead of going up 6, I go down 6. 1, 2, 3, 4, 5, 6. So D prime is 2 and negative 6. Again, if you're graphing without graph paper, I expect you to label the point and give me the location. If you are using graph paper, you still need to put that is D prime. You still need to put the letter. The only thing you don't have to put if it's graph paper is the point itself, because I can count squares. So E is 4 and 1, so I'm still going to go forward 1, but I'm going to go down 1. So that is E prime. And F, I'm still going to go forward 7, but I'm going to go down 4. 1, 2, 3, 4. So F prime is 7 and negative 4. So should be the same, should look the same, although for some reason, oh no. Remember, you're flipping it downwards. So this point is here, this point is here, and this point is here. So it's sort of backwards, right? It's just like looking in a mirror. It is backwards to you. All right. I want to go over one example out of the work because people don't know what to do with it when I assign it. So I want you to, it's not that it's hard, it's just people misinterpret what the directions are saying. So I want to look at, I'll get it, just a sec. I want to look at 16A. It's a whole table. We're just going to look at the first piece of it. It says find the coordinates of the image of each point after a reflection in each axis. So for A, the point they give us is 1 and 4. So in the table, they want to know what would be the new coordinate if I was to reflect it on the x-axis. Well, if I was to reflect it on the x-axis, that would mean I change the sign on my y. So it would be 1 and negative 4. And then they say, okay, what if I were to reflect it in the y-axis? And they don't mean reflect that, they mean the original point. So if I were to take 1 and 4 and I were to reflect it in the y-axis, I would change the sign of my x, and it would be negative 1 and 4. You don't need to do anything with it. They just ask what the point would be. So not hard, but people just tend to misinterpret the directions on that one. That's really all I have to talk about today. Nice, simple day. I will post some questions for you to try. The next video, I will go over any of them where you were required to draw, just to be sure that you have them right. Again, I don't go through and look at every single point of every single person's drawing. That's your job. So if we were at school, I I would start each class by going over any questions plus any that required you to draw the graph so that you could look at yours and make sure that yours look like mine. So we're going to do the same thing with this, okay? So your responsibility to make sure that you know how to do this. You guys have been doing really, really great with that. So just keep it up, all right? And have a good weekend. Stay.